Hi, Emily. So I had your questions. They are very meaningful, but in some of them you're right, which I made the corrections and I uploaded the correct Desmos one, but some of them you're not quite right. So I just wanted to record this video to clarify misunderstandings, let's say. So first, I'll try to take my visual off the screen if I can. I don't think I will be able to. Anyhow, let's go ahead and get started. So yes, on slide number 13, you were right, the factoring was wrong. So when you factor x squared plus 5x minus 6, right, so multiples of it and multiples of it plus 6, -1, right? Because when you multiply them, you get -6. When you cross multiply them, 5. So this should be the correct factorization. Before, it was written as x minus 6 and x plus 1. This was wrong. All right, so I corrected that. So this is the correct form now. So if you log in back again, you will see this form there. However, this is where I think you might not think correctly. This is the correct binomial. Then in this case, the root of the function x plus 6 equals 0 will be equal to -6. This one equal to 0 will be equal to 1, which is what we are seeing in this picture here, -6 and +1. So this is correct. I hope we clarify this misunderstanding. But again, thank you. I have corrected the mistake with the factoring here. Now, slide number 14. So if we go ahead and find the binomial factors of it, right, you will get this form. Then here we will need to equate each of them equal to 0. So we will have the roots 9 and -2. So this is what we're having here, right? So this is 9 and that is -2. So just because we're seeing -9 here doesn't mean that the root will be -9. You need to make this portion, each binomial, equal to 0 and solve it. And actually it will turn out to be the opposite side of it. Okay, so that's the -2 there. All right, then the last one. Now the last one is a little bit complicated and different because look at the scaling with the last one on the graph. So it's not going 1, 2, 3, 4, 5. So if this is 10 here, it's going by 2s. So this is, for instance, 2, 4, 6. Oops, no. All right. Okay, so it is going 2, 4, 6, 8, 10. So it is going, so this is 0. Yeah, okay. So this is origin. Then it is going with 2, 4, 6, 8, and 10. Okay, same. The scaling here is 2 on the y-axis, 4, 6, 8, and 10. So when we look at our problem there, okay, let me take it up here. So denominator cannot be equal to 0 on the rational functions, which means that we're going to claim x squared minus 7x minus 18 cannot be equal to 0. So we first factor it. If you factor that, right, so you will get x minus 9, x plus 2. So x minus 9 cannot be equal to 0. X plus 2 cannot be equal to 0. So you do this as if it is equal to 0. So x cannot be equal to 9. X cannot be equal to negative 2. So what does that mean? If you go to that picture, because the scaling is going by 2, so this point is actually negative 2. And that's why we have a vertical asymptote. So these two will produce vertical asymptotes because x cannot be taking these values. This is what vertical asymptote means. Vertical asymptote provides the function to become undefined, provides security for the function to become undefined. Vertical asymptotes are the values that x cannot be. Are the values that x cannot take. So then, if we agree on it with the picture, right? So what is happening there for the domain? So we are going to become coming from the negative infinity till negative 2, but we cannot be, we will never be equal to negative 2. Union, we're going to take all the values between negative 2 and 9. Union, and we will go from 9 to infinity. I believe I did not check that. Is that the activity was saying? Or let me look at your picture. Alright, I think so. Oops. Picture is not wrong. Picture, it should be correct. So let me see what we're doing here. Yeah, negative infinity, negative 2, negative 2 to 9, and 9 to infinity. Yeah, we're correct. And picture is correct also. Because the thing with the picture was scaling. So be careful about the scaling. Alright, hope it helps. Have a good night.